Guys, Dwight Merriman is one of the most influential people in technology. When I met him today, this was the first time, I got a little giddy. I was like, hey, it's very nice to meet you. I've wanted to meet you for so long. And I probably weirded him out a little bit, and I'm very sorry about that. But honestly, I don't care, because you're a big darn deal, and we're really thrilled to have you here. For those of you that may not know, Dwight Merriman, again, founder, original author of MongoDB. In '95, he co-founded DoubleClick, which was eventually acquired by Google. He served as a CTO for 10 years. He served, earlier he was a co-founder, the chairman, and the original architect of Panther Express, which is a content distribution network, or CDN. And then he's also a co-founder and an investor of Business Insider and the Gilt Group. And Dwight, I think you're visiting us from New York,
yes,
if I'm not mistaken. So thank you very much. We can't thank you enough for being here.
Thank you.
Yep.
Hi, everybody. How you doing? See if I can get this thing going. So hi, I'm Dwight. Work at MongoDB, and as you mentioned, have been involved in the project from the start. Some other folks helped from day one too, but I definitely wrote a lot of code in the version 1.0 days of the project. So what I wanted to talk this morning about is I think very consistent with what Jeffrey was talking about this notion of modern applications and how things have changed a lot. It's very easy to see this if you're old like me, and you remember, things like Kokomo model and waterfall SDLCs and pre-object-oriented programming languages and all that good stuff, relational databases, even before that. So that's, that goes back a ways. So I'm going to kind of just turns out coincidentally, it's going to be kind of the same theme a little bit, but I'm going to focus a little more on a specific piece, which is the data layer, since that's kind of what I know best. But I do like that term, kind of modern application, because I think we're not building the same things, right? It's not, oh, we need a new version of the inventory system. We will on occasion, but we also need this whole new class of applications, both B2B and B2C, that just didn't exist before. And in addition to that, the way we build them is completely changed, and how we do that. I was looking at the schedule this morning, and just the big roadmap atlas, whatever you call it, and just you see all the talks, but you'll see peppered throughout the titles of the talks is the names of products or projects or software, and a lot of open source things like MongoDB, but there's a million of them in there. And one thing I was thinking about when Jeffrey's talking about these different aspects of open source software, such as he's talking about like elasticity of licenses and things like that. One thing that I think in my mind is a big deal is that it gives you granularity with the software. In other words, as the Netflix example showed a little bit, it's easy today to kind of mash up when you build your system or application using a bunch of third-party code, right, that is completely separate products, right? So you could imagine building an app and using a dozen third-party pieces of software or more, right? You might be using Memcached, you might be using a database, you might be using some queuing software, and you might be using Git, and so it could very easily become an app server. It could very easily become a very long list, like 20. And I was just thinking about this morning that if it was closed sourced, it would just be hard to have that many different things to just go get, to go buy, to go evaluate. And so I think that granularity aspect is very real, and it just fits very well also with the way we write software today, which is kind of very modularized or compartmentalized, right? That kind of service-oriented architecture type of thing, even if it's a different dimension in some cases, where you've got to kind of divide and conquer. I don't want one big monolithic system. That's how you get into kind of mythical man-month, project schedule misses. We want to break everything up if we can, right? And so using lots of different pieces to do specialized things makes a lot of sense to me, but I think it might be hard to do that if they're not open source, because just, boy, I got 25 things to go by, right? So that was just coming to mind while he was talking, and I thought it was quite interesting. So yeah, so in that context of these modern apps, I want to talk about data. And you know, I think there's a lot of buzzwords out there: big data, quote unquote, NoSQL, quote unquote, and they're kind of weird words and imprecise, I'd say. But there is something very big happening. I think we're in the midst of the biggest change, kind of technology change in the data layer of IT in 25 years. So there is something big going on. So it's really, you say big data, it's like there's a bunch of new technologies in the data layer that are happening right now that are real important, and it's an unusually large change, right? So that's a very boring but accurate way to describe big data. You could also look at it and start dividing out, well, what's underneath there? What are the products? And I think, one bucket is the NoSQL database technologies, which are these new next-generation database technologies that are horizontally scalable and really good for building these modern apps. And then there's also things like Hadoop is another bucket under big data, which is more on the analytics side of the world. So all this stuff is happening, and it is a big change. And I think it's a very important change, in particular because just the types of apps we're writing has changed too. So in regard to that, these new apps and use cases we're working on, right? So the shape of the data is different. Right, so I like to talk about the shape of the data. We're dealing with a lot of unstructured data, semi-structured data, object-style data, polymorphic data, right? So that's kind of what I mean by shape. It's not all tabular, right? If we were writing an accounting system, the real-world data is columnar or tabular, right? In the real world, right? So we're not mapping to some other data model. It's one-to-one, right? But there's a lot of use cases today where the real-world use case data it has all varieties of shapes. Either unstructured on one side to it's structured, but the structure is complex, like i.e. polymorphic, for example, or maybe it's evolving, it's plastic, right? So, and I think these new tools we're seeing today are at times very good at dealing with this, right? So these things, for example, things like JSON, right? And this document-oriented notion, whether it's a database or something else, or just a message passing in that format. So this is quite significant in my mind. And I like to say it this way, because just saying unstructured data, I think that's inaccurate, because usually this data has some structure to it, right? So, and if it doesn't, what are we going to do with it? Text search, right? But it does have structure, but it's dynamic, right? It's a little bit like dynamically typed versus statically typed programming languages, right? Which each have their pros and cons on both sides. The data out there that we're dealing with is dynamic, and I like to think of it that way. I mean, another requirement we have to deal with these days is just size, right? So this is the big data part in the classic sense of the term, right? I got massive scale, and how do I deal with that? And the computers I have today are they're cheap, but they're not very tall. I need to scale horizontally, right? And I think Jeffrey mentioned an anecdote about how much it cost to start a startup in 1999, and I remember back then I was at DoubleClick, and I think in 1999 we spent about $100 million on hardware. So we were serving a lot of ads, but on the other hand, computers were 1,000 times slower then than they are now. So it cost a lot of money back then to do things like that. But the computers were they were tall in the sense that you could get a big computer; it was just expensive. These days, you can't really do that, right? Clock speeds aren't really going up on CPUs. Cost per transistor is still going down exponentially. So Moore's law still works, but what we're getting is a big wide system where we need a lot of parallelism. And so at all layers of the application stack, from network all the way to the top, we're going to need to have parallelism, and that means horizontal scaling. And that dovetails perfectly with cloud computing, where that's the standard way to scale out too. So we've got this imperative to scale out just for size reasons, and then this is the only game in town, so to speak, as far as how to do it, is this horizontal notion, so we need that too. The third thing we need is speed, right? And there's a couple different possible meanings of this, right? And the main thing I'm actually thinking about is sort of latency, and the notion of an application or use case requiring real time, right? Getting nightly reports, or morning, you get yesterday's report in the 8 a.m. in the morning in your mailbox or whatever. I think we all think that's kind of old school at this point. People expect like real-time interactions. They're used to it on their smartphones with all these services they deal with. They want to do things in real time and all that kind of stuff. So we really, as developers, as we build systems, I think we have to start from a real-time mentality. So if I were a CIO somewhere right now, I would tell my team, we're going to conceptually on the 100 apps we're going to build over the next 3 years, default to real time, right? And well, on the one hand, it seems kind of obvious. On the other hand, that's a big deal and a big change, because classically you're supposed to default to batch, right? So if we were taking a computer science class in like 1980, they would say do batch for everything because it's so much faster than real time. The algorithmic time complexity is so much better in all aspects that it's just the way you did everything. But these days, computers are faster, so a lot faster, so we can do it. And if you can do it, it's better. So, we have things like solid-state disk, which are great and which facilitate that too. We've also got a very connected world, right? Where it didn't matter if I did it in real time or not, if my delivery mechanism to just send you the report was the mail or FedEx, right? But now not so much. So this is a big thing too, and a change. And one of the properties I think of modern applications, if we kind of define them, and something we got to be able to do. So I would just, anytime I do a new app, I think to myself, I just by default think, okay, we're going to do it real time, and then we'll not do it in real time if there's a reason, right? If it's just, it'll cost too much or it's impossible, then you don't, right? That's why I use the word default. It's not always, but a lot of these new tools, like MongoDB and other NoSQL databases are kind of, I think, facilitate that too. Approach, so shape, size, speed, approach. So approach is, what I mean by this is how do we approach the problem? Or how do we write code these days, right? And that's changed a lot, right? We're not doing this kind of architect, design, code, test, deploy. It's now we're doing a lot of agile development, a lot of iteration, which I think works fantastic. And iteration is critical to successful projects for a couple reasons. One, on the development side, is just super helpful, but it's also just helpful with the interface to the business. Like, am I building what you want, right? So I start sketching it out, like in code, and then you tell me, no, that's not what I meant. Well, that's what you said. Well, that's not what I wanted. And then I change it, and we kind of converge onto a solution that meets all the needs. Because it's hard to spec things, right? It's very hard. And that also, I think, opens up the doors to some creativity too. Because even if I'm the business person, even if I could write a perfect spec, which I can't, but if this project's going to take a few months, if we're a month in and I'm seeing what you've done, I may have some ideas. It's like, well, can we do this? Can we do that? And I hadn't thought of those before, right? So I think you get a better outcome in that sense too. So that's definitely a big part of apps today, I think. And it's also just, like if you look at Facebook, they try, every day the site changes. Some little feature on the site changed or was added daily, right? For years, right? That's how they do it, right? So at iteration, right? And so that's a good real world example, I think. And then finally, I want to circle back to the use cases and the actual applications, which I mentioned up front, and give you some specific examples that I've seen recently that are out there. And I'm just going to pick one kind of category just to kind of have kind of a little bit of a theme to it, which is the ones I'm going to talk about are all Internet of Things related. I think it doesn't have to be Internet of Things to be a modern app. It could be almost anything. And I know that the usage I see of, for example, MongoDB, people ask me, well, what are the use cases for MongoDB? And I say, well, it's kind of a general purpose database. I'd call it an operational database, so it's very much an online tool by default. But it's the database. What are the use cases for Oracle, right? And it's like, well, there's a lot. So we're just trying to take a new cut at what is a database in an operational database in today's context and landscape, tools we use today, methodologies we use today, the use cases we have today. So Internet of Things is definitely one that's going on, and people use NoSQL a lot for, but just qualifier that people are doing a lot of things. So I just don't want to imply that it's the only thing. So one interesting application is John Deere's doing some very neat things with data these days, and you can imagine. I think they're doing a lot of things, but and I don't know the exact details on this one. But imagine, it's harvest time and we're running a combine, and we're doing the field, right? And we're going around it kind of like a lawnmower, and as we go around, you could measure on the combine today yield, right? You could measure how many pounds of stuff went into the bin, in the last 5 seconds. Or 1 second, or whatever you want, and you know where you are by GPS, et cetera, right? So we can map the yield. We can have a yield map, kind of like topologically, if you want, like of the field. It's very precise, right? And then, of course, that's a lot of data. So that feels very much the Internet of Things like to me. And then what do we do with this then? Well, we could do a lot of things. I mean, one, we could look at the data. We could look at it with a visual representation, maybe with colors and heat map. You can say, oh, I see the problem. Like the river's over here, right? And this part is low yield. And you could also imagine, though, that it could be very granular, right? Very like the size of this podium. Maybe this is a low yield area. You can imagine then in the spring going around the field again with a tractor and just fertilizing where you needed to, and not doing the rest of the field. Like just point by point by point, kind of trying to tweak it, and that's the kind of things they're working on, and I think that's really cool. And I also like just that these are very kind of real world tangible things. It's maybe Candy Crush is cool, but it's very virtual, right? And it's like this is real. Like this involves food and things like that that we need. So in the physicality, not just in the mental domain. Another example, and here is Bosch is doing a lot of neat stuff with Internet of Things. A bunch of things. I think they have a business unit that does a lot of software actually for automation and industrial automation, things like that, and management, business process management type stuff, or enterprise resource management stuff. So they're doing some neat things. Like one example is they have these, I forget if they're drills or riveters that kind of like a power tool, except that unlike the one you have in your garage, this one costs $15,000, and they use them to put rivets into airplanes, or one uses them to put rivets in airplanes. But of course, with the airplanes, safety is a big critical, right? So you need to have great quality control and all these things. So we need to know, are the screws or rivets, are they going in right? And sort of, and kind of rivet by rivet, we could look at it statistically. We could look at it, if you get 3, mediocre rivets within a certain distance, maybe that's a problem. Maybe if you get 3 over 100 feet, it's no problem. So what they do is the gun will actually, the rivet gun, will it'll record what it's doing as you're working. And then all that data will then be available to look at and becomes part of the quality control process for the manufacturer of the airplane. So that's pretty cool. And so that's another example. And of course, in all these cases, you got to store a lot of data, right? And that's part of what makes them interesting. The shape of that data, you get often there's a time series aspect to it. Obviously, there's a lot of timestamps, and there's a lot of little nuggets of information. And there's also a polymorphism to it if you want to think about just, if you have a bunch of sensors out there and they're not all exactly the same sensor, then you're going to get a bunch of telemetry and it's going to be polymorphic. So it's like, how well can you deal with that, both at the application level and at the data level in your tooling? That would be kind of a question. And then one final example, Diva, I'm not sure if I'm saying that right. I believe they're in Sweden. They're doing some very cool things that have to do with traffic management. If you think about cars driving, that generates tremendous amounts of data. And you can really use that both, if you have that massive data, both to do analysis for trying to improve traffic flow, and figure out, maybe where you need to change something or add a road or something like that, and what's the problem. You can use it for safety analyses, right? And they're doing some other interesting things too. One thing they've done is they've built a technology which will, when you're driving across this big bridge in Sweden, they see your speed, right, in the radar. And if you're going the speed limit, it does nothing. And if you're going too fast, the system will start creating speed bumps for you. And they can be subtle, right? And I believe it actually creates depressions. It doesn't go up, it goes down, but it doesn't matter. It's kind of the same thing. And I think to some degree, just as soon as you start feeling them, it could be subtle. It's a reminder about the speed. And then you then probably also think, I know it's not going to go away until I slow down. And so they've seen, like on this bridge, and of course bridges can be very congested. And if there's an accident on the bridge, you may ruin traffic for 500,000 people for the rest of the day, right? Because it's a bridge. So there's a much higher cost on the bridge than on the back road, which would still be high. But so that's pretty neat. And then they can take all that data and analyze it. And it's been a very successful project for them. And although I have mixed feelings about not being able to speed, but I do like the idea that I don't get tickets then. So that's the good thing. But anyway. So looking at those examples, I mean, they're Internet of Things examples, so we can get broader than that. But the question I would put out to everyone here is sort of, what are you working on? And by that, I don't mean like literally the second, but what are you working on over the next year? Like, what are the new projects that are in the pipe? And are there interesting things, creative things? I think, we've seen a lot of interesting things done by startups out there. Uber would be an example, right? That's pretty real worldish. But I've also gave you some here that were from very classical kind of organizations. The point being that there's new stuff to do in all domains, in all fields, as far as apps. That's completely different than what we were doing before, and we have the tools to do them now, but we have to make sure we kind of adopt that mentality a bit and to be ambitious and try to tackle these things. So as mentioned, there is a talk to the speakers in a cage out there. It's just right out here to the right. So I'm going to go over there after we finish up. And how are we on time?
Actually, we're fine on time. I've got about 10:08. So you got a couple minutes. We'll go to 10:10, and then we'll just be running over about 5 minutes, which we can make up during the next
Okay, so maybe if somebody wants to do a question or two, let's do 1 to 2 questions, and then I'll do some out there that. But there might be a line out there, so that's the incentive to do one here.
Are there any questions at all from anyone? Bueller?
Anyone?
Everybody here old enough to even know what I'm talking about when I say Bueller?
Yes.
Some people that are not. Same details, but anyway. Okay, well, hearing none. Dwight, thank you.
Thank you.
Yeah, thank you
Okay,
very
thanks,
much.
everybody.
It's been-